Okay, cool. So I'm going to start sharing my screen. Can someone let me know if that's visible? I can't see or hear anybody.
We can see it.
Cool. So hello from Valencia, Spain. I'm Eoin, the CEO of Kyso. The cool, I suppose, like, yeah, everybody's having hard times, but one of the cool things is that I'm pretty happy to be able to talk from this far away. It's lovely and warm here now. I think it's probably warm in Berlin too, is it? So the topic of my talk is that everybody here, companies and research groups, should have a formalized or systematic way to share and allow others to discover their data insights. I'll tell you a bit about myself and then kind of how and why I came up with this, and like currently my company is trying to solve this problem. So like I used to work in building quantum computers and modeling quantum systems, and I used to work in big research groups, and the issue was that the sharing of analysis reports was very, very messy. And obviously that's only getting worse now because everybody's forced to work from home. So for example, I was in a team of like 20 people making semiconductor chips. We would create them. So they were like little prototype quantum computers. So we would make them, we would test them, and then we would analyze the data and simulate the chips and then try to, you know, make them better. The problem was that we had no central system for like all of us collaborating and sharing the results. And the results were like typically presented. We would a lot of us would do the analysis in Jupyter notebooks, but then we had no central place to post those. They were just like sitting in a shared drive, unlabeled. Some people would do their analysis in OR and then save it to a PowerPoint, and then that would just like get presented once to the boss and then get dumped in a folder, and no one would ever see it again. And this caused loads of trouble for us. So I eventually got really frustrated, and I started building a solution, which is what I'm going to talk about, but also just I'm going to make the argument in general for a kind of a systematic way for sharing results. So what I'm going to cover today really is the difference between the discovery and sharing of results that other people make. So we all do sharing, that's like one-to-one, but then actually discovery, allowing other people to discover your work, is very, very important. And then I'm going to go through like two really common like archetypical examples of companies or research teams, and how still having a centralized place for results is really helpful. So I'll go through a typical, say, startup or organization that has data scientists, but also has multiple different types of stakeholders, so like marketing teams, executive teams, sales teams. And then I'll go through an example of like a deep tech company or like a research group where say everybody in the team is technical, but there's still a lot of value to be gained from, you know, sharing your results in a kind of a formalized way. And then I'll go through kind of my way of setting up our team or teams that I've worked on for kind of reproducible Python, Jupyter data science projects where, you know, we crunch the numbers in Python, typically within a Jupyter notebook. It doesn't have to be, but then, you know, setting the project up in such a way that it's version controlled, the project is reproducible, but also then a place where we can host the project so that it's very, very shareable. And then everyone else in your team can kind of discover it. So generally, data science reporting is a mess. The difference then, a key insight I want to get through here is the difference between discovering and sharing. So all of us are every day sharing. You know, you look at your colleague's screen and they can show you their results. You can make presentations to people in groups. You can email your boss or your colleague a PNG or an image to make an argument to them. You can talk on Slack. You can physically talk over coffee. So that's very like one-to-one sharing, right? And what happens then is that like kind of data insights get kind of siloed within groups because of, you know, I'll share with you, you share with your friend, but then maybe the chain stops there. And then someone else who we don't even know could benefit from the data insight, it just doesn't reach them. So that's why discovery is really important, where you have one place for all of the results that people you haven't even thought of using your results can discover it and use it in their work. So discovery is like a key factor that I think a lot of groups and companies don't get, and it's super, super important. So like, just to give you a general kind of view of like the kind of systems I'm arguing that people should be setting up, it's stuff like Notion, like Confluence. Airbnb have created the knowledge repo, which is a place to post Jupyter notebooks. People do this in general on GitHub as well. I don't think it's a great solution. A lot of people, like research groups in universities, run internal WordPress as a kind of a way of sharing results throughout the team. And there's like a ton more, right? Setting up internal blogs, whatever. So here, like, I'm going to go through the 2 examples of like the different types of companies. So let's think of a company called Acme. It's just a general online SaaS company that charges per seat, like per person on a team that's using the product. And the CEO, James, just wants to like find out more, like kind of get a better overview of the customers. So he asked Sarah, the data scientist, to make a report of user behavior. And what Sarah comes up with is this. She starts working in Jupyter. What I'm showing you now is a Jupyter notebook hosted on Kyso. Sometimes they don't work on GitHub. So this is like, I can show you the code here. Is that visible? I'm getting a lot of Zoom things coming up on my screen. I'm not sure if you're seeing that. So what's happened here is, you know, Sarah has taken company data that was on MongoDB in a database. It was on Mixpanel, it was on Google Analytics, and she's plotted out like various key pieces of data about how the customers are using the platform. So like a really quick example, a quick piece of knowledge to learn is like, what's the distribution of team size? This is just a simple histogram. You take all of like the teams and you take the size and you just make a simple histogram, and it shows you like kind of like half of a Gaussian. Average team size is somewhere about 200 or more, but like a lot of small teams, less than 200, some teams over 500, and that's pretty interesting to know. And then what she does is she like publishes, she studies the number of articles. So say if it's GitHub, that would be like the number of repos. If it's Confluence, the number of articles. If it's Notion, the number of articles. The number of articles or posts per team versus the size of teams. And what she kind of discovers then is there's actually like a super linear dependence on number of posts by the team size. So what happens is like teams of 400 or more use the system proportionally more than smaller teams. So it's some kind of cumulative or quadratic or exponential dependence. And it's the same then for like the number of comments made. And then like we could figure out why. Is this because like as teams scale up, is there just more connections between people that they chat more? You know, like I'm not sure, but I'd say the number of Slack messages like per group does not scale linearly with the number of group members, right? It probably scales super linearly. She's also plotted out like the page views or like the logins per team and the distribution of like say events on Mixpanel, right? So this is a fairly simple kind of piece of analysis that a company would typically want to know about their customers' behavior. And so now let's look at the case where Sarah like does this job and she emails it to the CEO, right? This is when they don't have a centralized system. The CEO then reads the report and that's it. So what happens is like Sarah might tell a few people, the CEO might tell a few people, tell the board, tell the investors, but the insight that there's a super linear, like above linear dependence on like product usage on the number of, on the size of the team, that doesn't actually get widely shared within the company because there's no discovery of this result within the company. So then we can like think of the case where Acme then decides to set up a central hub. Well, maybe they've been forced to set up a central hub for sharing stuff now because of the coronavirus. Everybody's working from home. They've decided to set up a central system. And we can look at what happens then. So Sarah posts the report on this central knowledge hub, on their Notion, on their Airbnb knowledge repo, on say Kyso, for example. And then what will happen, right? So everybody in the company can see it. So then Mary from the product team reads it, right? She didn't like think she was going to see this. Sarah didn't think of Mary, but Mary discovers it on the knowledge hub and she reads it and she says, oh God, this is really interesting that there's a super linear dependence on usage to team size, right? So then she's able to like kind of think about deep diving. So she's on the product engineering team. She's now, because it's been posted, the article has been posted to everybody on the team, she's seen it and she can now think of like her team's goal and she can deep dive into why this super linear dependence is, right? Maybe she'll see it is because of the number of connections between people on the team. Maybe it's a political issue in companies. The larger the company is, the more likely, say, a VP of engineering or an executive will be pushing product usage within the company. And maybe there's like a cultural, political reason for the product getting used more by larger companies, right? So this like insight is clearly very valuable to Mary and her product engineering team. We could also see that Patrick from marketing and sales reads it. And if the company is charging per seat, then it's extremely interesting to them because he'll have a fixed marketing or sales budget. And now what he can do is focus in on larger team lead sizes, right? So you can take all his leads and start focusing on the larger teams or the potential to be larger because they make proportionally more money from those kind of teams, right? So then clearly now that they're sharing in a kind of a systematic way, this is clearly relevant, a relevant insight for Patrick. Then say Barbara from the infrastructure team, maybe the cost of providing this service is not linear with, or is not flat, right? It's not like hosting a blog. Maybe there's something else to it. And Barbara gets worried that, you know, providing the service to larger customers is just much more expensive, and they have to figure that out. They have to make their systems more scalable, or maybe they want to get more smaller customers, right? So that's like an example of just a typical company, and how moving from having no system for curating and having discoverable like a central place for results, like notebooks or lab notebooks or whatever, to moving to a central hub, and then like how the productivity can get driven within the company. And now I'll tell you, maybe some people here are like working in research groups or in like deep research companies, where say the difference between like a research team and like a kind of a general team is that in a research team, everybody might be technical, right? But here I'll show you how, like in my experience, having worked on a few like semiconductor research teams and like photonics research teams, that the lack of a central place to share results caused us a lot of frustration. And we really would have done better if we had a central system. For example, the lack of sharing of, say, Jupyter notebooks that we were all working on stopped us from developing on top of other people's work. So, for example, when I was on the semiconductor team, we used to make these chips. Then we test them. So what we would do is we'd shine lasers through them, and we were trying to make basically computer chips using photons instead of electricity, instead of electrons. And so we'd shine lasers through them. We would try to excite like quantum photonic states in the chips. We would take the data. We'd always be looking at light spectrum, right? So like a common thing we had to do was to like fit Gaussians really, really well, and maybe like an automated fashion to just like tons of spectrum that we were measuring. Everybody on my team, about 20 people across 10 labs, we were all measuring spectrum. We were all fitting Gaussians all the time. And we needed like sophisticated analysis. Like you had to have proper error management, all this kind of stuff. You wanted to make sure that, for example, like it could automatically pick out Gaussians from noisy data. So you're not spending your whole day just dragging a slider to peak of Gaussian. But 20 of us had a different way of doing it. So a few of us used Jupyter notebooks and Python. Some of us were using R. Some people were in Excel. We had no like central place that we could post. Like I could post my notebook, and then the person in the lab next to me could come along and reuse that notebook and then improve it. So think of like two teams, one of which everybody's building on everybody else's work all the time. And then after 5 years, they've just got like a beautiful like system in their lab for, you know, analyzing data. It does proper error management. It's fully automated. It runs really fast. You don't need to be doing any manual data prep. And then think of a team that doesn't have this, right? They don't have the central place for sharing the work. They just stay as they are. You know, they're all doing the work alone. And then another like, horrible thing happened, which is that because everybody in my team would like keep their notebooks to themselves, or their insights in a way to themselves, we had a guy leave the team, and I wanted to continue his project. He had kind of an interesting chip design that I wanted to integrate into I was making like a hybrid chip system. I literally glued chips together. We wanted to use some of his chips, and he left the team, and I could not recreate his work, and we had to abandon the project because we were on a network drive. I could see his data, I could see his notebooks, I could see his PowerPoint presentations, but they were all like messed up, you know? He had never like curated or set them up to be pushed to a central place for everybody to read. So it was just like his own folder, which was an absolute mess. Even like emailing him, that was a thing. So it doesn't even apply when someone leaves the team. It also applies to yourself from like a year ago. So like I rang this guy and I was like, hey man, I need to get this project going. Can you help me? I got all of these folders. Can you tell me what's in here? And he's like, I don't know. I did that a year ago. I can't remember because I didn't, you know, put it in a place that we could all read from. I didn't prep it in a way for us all to read. So we had to abandon the project. And this is a 4-year project making semiconductor chips. That's like a lot of money wasted. And then another thing, so I was later on working on a project where we were in Ireland and in Cambridge in the UK, and we were making like automated optical water sensors. So we would have a microfluidic chip, like a little glass chip with a load of tiny little pipes going through it. And we would put water through it, and we would contaminate some of the water with E. coli or different bacteria. We would shine a laser at it, and depending then on the spectrum that came back, you could tell if there was or wasn't E. coli in the water, right? So I used to do the laser shooting and the data analysis, but we had a PI in charge of the project. We had the person who would like set up the E. coli concentrations in the water, and we had the people making the microfluidic chips. And I used to like work on GitHub, and I would just like show them my notebooks on GitHub and expect them to read it. And I realized that, you know, people can be on a technical team with you and they can write code, they understand analysis, they understand the entire project. They might not be technical in the same way as you. So my PI was like, man, I'm not on GitHub. I'm not going to sign up to GitHub. I work the way I work. The biologists in the team were like, look, man, I just want to see the results of the experiment. I don't want to be reading your code. I don't want to be reading your methods, right? So often, like when you have a notebook, it's much more relevant to the other people on your team when you're sharing the results and like the discussion of the analysis with them than showing them your like mathematical methods, right? So those are like some reasons. There's like when you have a central place for if you're like in a deep tech or a research team, those are some reasons why setting up a central place for sharing your data analysis is really, really useful, because reuse of work goes up. You have full transparency into what everyone else is working on. You don't have issues with someone leaving the team and you can't figure out their work. You don't have issues with forgetting your own work from a year ago. And you got to remember then that people are always not technical in the same way. You have different stakeholders with slightly different positions, even on technical teams. So those are like the two. I hope there I've convinced you like why having a central system or some central way to share your kind of database project reports is useful across, say, two types of organizations, like a common company, a general company with multiple types of stakeholders, and then also like the technical teams where everybody's probably technical, but they might not be on technical in the same way. And this is kind of what I came up with across the teams I worked on, like a fairly straightforward way to share like data analysis projects when you're working in Python. So one is that, and I'll actually show you like live here as well. So one is that your data narrative goes in a Jupyter notebook. Here I've got a really quick example project, which is just, you know, connecting to an example MongoDB database where I'm plotting some of the stuff that's inside it, right? What I always do is you put the data story in the Jupyter notebook. And then what you do is you use the README, for install instructions, right? So that means that if someone comes across the GitHub project, they open up the README, and the README is where the installation instruction goes. So like how to set up the project, you install Anaconda, you install Jupyter, you start it. Then you always have to give them instructions about how to get access to the data, right? So in this case, it's just like getting access to a Mongo connection URL. It can also be, you know, getting the security team to hand you a hard drive. It can also be, you know, Jenny from data analysis setting you up on the Mixpanel account. You always have to put in your instructions there for how to get access to the data. And then like the other thing then is always use Conda for, like you can use Docker. I'm sure people here are familiar with like how to use Conda and Docker, but just always do it. I've worked on so much teams where people would just like open a notebook, bring in a file, plot the file, have the graph, take the graph, email it to someone, right? And that like does generate an insight for a day, but long term, it's effectively useless because nobody else can come along and reuse the project. Nobody else can come along and be able to tell what the insights gained were from the project in a systematic way. So like always have the data story in Jupyter, have a README for the install instructions, use Conda and an environment like YAML or Docker. Then make sure you push to GitHub, like just like you have to. I've been on loads of teams where people would not version control. I probably don't have to explain this to people on this call, but there's enough teams out there where they don't version control, or they version control in a really messy way. So you just have like a load of Git projects with one file in them. There's no README, there's no organization. And so then the last thing I would suggest is if you want to share it, there's platforms out there where you can like take your report, you can like write an article in Notion and you can link to this GitHub repository. So you've got your like insights in the Notion article, you've got the link then to the Git repository. You can set up Airbnb's knowledge repo where you can upload your notebooks. Generally speaking, looking at notebooks on GitHub has become redundant because it just doesn't work like a lot. And then the thing that we made basically is Kyso, where you can post a lot of your team's notebooks into one place and they just look like blog posts. You can set up connections to GitHub. So I've logged into GitHub from my Kyso account. I can just search for the project there, and I can bring it into Kyso. Oh, one thing I forgot to mention is I always add like a Kyso.yaml, or it can be another kind of file, metadata somewhere with like the title and description and tags for your project. On Kyso, then what we do is we import the project, we take that Kyso.yaml, it becomes the title, the description and the tags. And then you can have a look. And then what's happened is you sign up your whole team to Kyso, and now everybody in your team can read this analysis. It's not just limited to the technical members of the team, like it would be on GitHub. You don't have to spend time writing stories into Notion. You can kind of do literate programming where you tell the story about the data in your Jupyter notebook as you're creating the story essentially. And then like obviously there's like links to GitHub. You can view the code on Kyso. There's also like what a lot of people do is I showed you an example there where there's just like one data project in a repository. So this repo here is like one data project. What a lot of people do is because there's so much library reuse across projects, what they do is they'll have like one repository where there's like a common data extractor file. So say it's like connecting to your data sources, and then like many different data analysis projects within the repository. You can also import them and they'll just come up as different posts on Kyso. And all this is free. It's free to get started. It's free for smaller teams. So give it a go if you find it useful. So yeah, so that's like, how you can share data, Python data science projects. Data story goes in the Jupyter notebook, always have a README with install instructions, always use some kind of reproducibility system like Conda or Docker, push it to GitHub and make sure you tell your story somewhere and you'll see a lot of benefits. So what I covered in this talk, and I hope I've convinced you to set up some kind of central system for analysis and results sharing. Discovery is a lot better than sharing. Don't do one-to-one sharing of emailing of talks and stuff. Make sure you have a central place that everybody can have a look and learn from what you're working on. You never know what you're going to find. It's kind of like, you've heard the phrase, a death by 1,000 cuts. This is the exact opposite. It's like huge productivity benefits from like a lot of small improvements that you get when you just have full visibility onto like what everybody else is doing. We went through two types of companies. Hopefully one of these use cases covers you, which is like you're a general startup. They get a lot of benefit from everybody seeing the results because different stakeholders can learn what's going on and then drive their own productivity. And then like deep research teams, like where I used to work, which was a nightmare without a central system, why you should set up that kind of system there. And then like my simple guide my simple way of setting up Python data science projects using like READMEs and Conda it gets you 90% of the way there for like having a decent reproducible project. Thanks for listening, and I'm super happy to answer any questions you have.
Okay.
Clap, clap, clap.
Thank you.
Eoin, for the presentation, and we already have some questions. We aren't source controlling notebooks in my team yet. How good is GitHub with this? And how do you make sure things stay reproducible other than environment?
Yeah, so I mean, use GitHub. Notebooks don't play super nice with Git. There is a tool out there called what's it called? It's NBDiff, I think. So you can, it'll diff notebooks for you. You can set it up with a Git hook and stuff, so that when you're like diffing, it'll run. There's a company out there that actually is an add-on for GitHub. So what happens as pull requests come in, it'll do the diff for you and like open. It'll put a URL in the pull request comment, and it'll give you the diff in front of you, and then you can merge. So that gets you like pretty far. And making things reproducible. So like use Conda or use Docker. And then for data tagging, so there's a question here. Is it possible to link the used data sets to the shared analysis? This way people could discover who else has used a data set, maybe via adding a tag for each data set. Not sure. Well, I think that's like who has used the data sets. And I think that really depends on the type of data you're looking at. If I'm doing a connection string to MongoDB, we're probably not going to be tagging that, like that actual data connection. So one thing like I'd recommend is that like no matter where you have your data, so like frequently I used to either pull data directly from databases or from big shared drives, like EFS on Amazon, or just like a Microsoft drive in the office. And you always want to have like a raw data folder and like a processed data folder, and just don't go mixing raw with processed, which a lot of people do, and it makes an absolute mess. Yeah, questions about like how you manage code version control versus data version control. Yeah, so I don't really have an amazing answer for you on data version control. It's kind of a separate question.
Have you worked with DVC? I guess that's the name, if you're familiar with it.
TVC.
DVC. It's like Git for data and models and stuff.
Yeah, so like we're kind of like, well, what I'm proposing here is that you have a central system for sharing the reports, right? Not for like necessarily version controlling data. That is like a problem that you'll probably have to tackle anyway. But again, people's data is so uniquely saved. That's a very open-ended question. So what I tried to cover there is really like, no matter where your data is, you're going to probably process it in some way and then present the results you're processing, right? If you're doing like data analysis, not if you're doing like ETL pipelines or something, you're just sending it off somewhere else. But if you're doing analysis, you're looking at data and generating a narrative. And what I'm trying to cover here is like you have to share the narrative that you've got from the data in like a systematic way. Version control of data, that's a pretty open question, and I'm not sure like I can give you great advice there unless you talk about what this use case is, the specific type of data.
So Dino asked if you offer on-premises solutions.
Not yet. We will someday.
Okay.
Someone put in the link to NBDime. Yeah, I thought it was NBDiff, but yeah, the tool is called NBDime. Ryujan there put in the link. If anybody like has trouble version controlling notebooks, it's super handy. Publishing data so different teams can benefit from a single report is great, but how do you deal with the problem of different teams using different languages? For example, a previous company, this person, I don't know, worked on in the team defined ROI as cost divided by revenue, another defined as cost divided by revenue minus 1. This is typically solved by a corpus, but it's very hard to build one. Different languages in terms of programming languages, or different languages in terms of like different you know, algorithms or definitions of statements used across the company. Like data, like if you have like ROI defined as something, I think there's tools out there like Colibra that will do that for you. That is, again, like that's something that maybe is like solved company by company, of like defining your terms, having a universal definition. In terms of different languages, if you're like, so we like support Jupyter notebooks, but also we just support, you know, if you have a project, say it's in R or just Python scripts without Jupyter, or it's C, and you're doing some analysis and you're generating results, which are typically graphs, you can just use a README file and link to the images, you know, as you're working, and that's like supported by us. That's supported by GitHub, also. Yeah, languages as words used in a report. I think that's like a company by company decision to make about how you'll define words across the business. I'm not sure of any good systems for defining words across code, like checking definitions of things. Maybe Colibra is what you're looking for.
Okay, any further questions?
I guess not. So you
support anything which has a kernel for Jupyter. What we do is we render the Jupyter notebook itself, so it's completely agnostic. We don't actually run the notebooks. So we take a notebook that you've generated on your laptop or on your server. You've pushed it to GitHub. If you import it into Kyso, it'll render because we render the Jupyter format. So that's like doesn't really matter. That's independent from the kernel. So you can use any kernel.
Okay. Maybe one more question, if there are any. There's a discussion starting about glossaries and corpora. Okay, so then let's thank Eoin for the talk.
Thanks for having me.
And I don't know what happens next. Adrian, do we have another awkward break?